Good evening, friends. Today we now discuss what is hypothesis and what are types of errors. We have discussed quite a lot of things, and there are other things which we will cover also. So now moving on to this module, let me just first define what is a hypothesis. A statistical hypothesis is a claim or assertion either about a single value of the parameter or about several values of parameter or about form of entire probability distribution. Now, this is a statistical definition, but before going into that, let's have some philosophical understanding of things. Whenever you are trying to do something, you take an assumption, and that assumption is strengthened by observing some other people doing it. Suppose you say job is good or job is bad, whatever it is. Suppose let's say job is good, and then you say people who are doing job, how happy they are or how prosperous they are. Now you get an evidence, okay. This will strengthen your hypothesis or this will weaken your hypothesis, okay. Either this will strengthen your hypothesis or weaken your hypothesis. So what does strengthening means? Next time when you will look at it again at this hypothesis, if you got a contrary evidence, your belief in the hypothesis will not decrease that much. Ideally, whole probability of statistics is about belief validation. I will be very frank about this. We wanted to touch this, we could have touched this, but then this would have been a much more philosophical thing, and those who want to study this can study Mr. Bayes' work. Bayes' theorem is a very good theorem, it's conditional probability, but it's actually about philosophy of belief validation. We have a belief, we make an assumption about it. So if God exists, then God exists, then if I pray, God should give me something in return. That's an testable hypothesis. So hypothesis is a testable assumption statistically, okay. Now when we come more into statistics, it says either about a value of a single parameter, okay. So what are parameters? So parameters are simple things we are trying to predict or trying to find, like what is the average height of the Indian population, or what is the average weight, okay, or what is the eyesight, okay. So these are all parameters, or about several parameters, again multiple lists, or about form of an internal distribution. So the sample is normally distributed, not normally distributed, or having a different distribution. We will talk about distribution more in detail when we cover this, after we cover this. So in this way, hypothesis is a testable assumption based on some facts which you have or which you invite yourself from some place, and those can be tested using statistical tests, established statistical test, okay. Now let's formulate some hypothesis. So hypothesis could be of this type: the average height of boys is 5.5 feet. That's it. So we now please go back to population. I am not talking of sample, I am talking of population, okay. I am talking of a population word. So average height of boys of the population we are interested, we have discussed about population earlier, is 5.5 feet, or average height of boys is more than average height of girls in this case in a population we are interested in studying, okay. So this is another, this is one there. Now these are very descriptive, as you see it is just very giving some values, okay. This is this, or this is more than this, this is less than this. Now there are hypotheses, other hypotheses like X causes Y, okay. If person is motivated, he will study more. Now there can be multiple theories about it, we will not talk about all of them. So hypothesis can be of multiple types, but the main thing is it is testable. And to make it testable, you have to design your study or you collect your data in that manner. That is more important. We directly should not jump to hypothesis, that we have to test hypothesis. And please understand, as we have discussed, unless until you do survey, we are going for survey or census of the population, we are going for inferential statistics. From the sample we will infer about the population, okay, and we can never be sure it is how much accurate it is, whatever parameter we are trying to find, okay. So generally hypothesis is applied in inferential statistics, okay. Because if I say the height of population, I am doing a census and I say the height of population is 5.5 feet, I do not need to find it. The question should be, what is the height, average height of my population if I am doing a census? Why to have a hypothesis? Because you can check it. If you can have the access complete the population, why to do hypothesis? As I told you, descriptive statistics is good enough. Just describe the mean of the population height, and that is the average height. But when we come to hypothesis, why are we going for a particular value? It's because we are just trying to be more sure. We are not sure. So, okay, let's put it this way. What is the average height for an Indian? So, we don't know right now, frankly speaking. But let us say it is near about 5.2 feet. Okay. Now, when I say it is 5.2 feet, if I want to verify it, what I will do from population, I will figure out people, and somebody I might find, हाँ ये 5.3 आया है, ये 5.1 आया है, या ये 5.6 आया है. So the deviation is there. It's not exactly 5.2. We know that. We did tell you that population parameter could estimate करना बहुत मुश्किल है until unless you do a census. So when you do inferential statistics, you are not close. You just try to be close to the parameter. Okay. So the deviation is there. Now, if I would have assumed that my average height is 6 feet, then the amount of deviations which I will get could be larger, because I will get 5.2, 5.1 and 4.11 and 5.6. So, I will get all varieties. So, therefore, we have an hypothesis, and we have a confidence in the hypothesis, which we will cover in next time when we talk about intervals. So, we never say my hypothesis, either I accept or reject. That is what I said, talk about the probability, the belief validation thing. If your belief is strong, your possibility of hypothesis validation is high. Okay, 99% I am sure today it will rain. I am 80% sure it will rain. This is subjective probability, though the concept is very similar. So, hypothesis is along with the probability level, which will come, or a confidence level, which we will talk about later. But conceptually, it is an estimation about the parameter, and we are trying to understand it. Now, what happens is, it is very important, the wording hypothesis, and therefore, next two words are very important. Next, null hypothesis and alternative hypothesis. What does a null hypothesis is? The mean is 5 feet, that is a null hypothesis. Alternate hypothesis, it is not. So, alternate hypothesis is very simple. We cannot say the null hypothesis is average height is not 5.5. Then what is the alternate hypothesis? The average height is 5.5. Because our target is to estimate. We are trying to come towards the particular value in the case of descriptive statistics. Okay. Now, when we go to causality, so we say X causes Y. This is our assumption. But because the word null is used, so we do assume that there is no relationship between X and Y. An alternate is there is a relationship between X and Y. So, please understand, when you will read papers, if so found to try to find out, or reports, So it may happen, our hypothesis is the relationship between x is causing y, and this is the p value, the probability value, and those sort of things. Actually, that is mentioning of the alternate hypothesis. So we test the null hypothesis, we might mention alternate hypothesis, but testing is of null hypothesis, and we will understand it more as we will go in different of distribution other pieces. Okay. Now, before going into some other things, it is very easy to say that either you accept null hypothesis or you accept alternative hypothesis, or you accept null hypothesis or you reject null hypothesis. That's all. Only two possibilities. Now let's come to this example. In judicial cases, people know that there could be errors in understanding the evidence, in understanding the context. Okay? They do understand that our judgment might not be 100% correct. They try to have multiple evidence, but still, as you know, there are multiple things called circumstantial evidence or other things where stories are created and theories are invented, and you might see different dramas about this, where same evidence is presented different way and different theories are presented. Okay. So we know that there might be an error in our decision. So we try to see which error is to be reduced. So please pay heed here. एक विचार है दोषी को सजा नहीं होती है तो दोषी छूट जाए, ये एक गलती है. दूसरी गलती है निर्दोष को सजा हो जाए. तो एक गलती है निर्दोष को सजा हो जाए और एक हो जाए दोषी बली हो जाए. आपके लिए कौन सी बड़ी वो है जिसे हम इंग्लिश में बोलते हैं इनोसेंट टिल प्रूवन गिल्टी इज वन कॉन्सेप्ट, गिल्टी टिल प्रूवन इनोसेंट. Now if you assume innocent till proven guilty, if you assume this, then you should have enough evidence to say he is guilty. Therefore people are relieved कि भाई ठीक है, we do not find enough evidence to prove him guilty, we are assuming innocence and evidence is not enough, hence वो बली किए जाते हैं. बली मीन्स रिहा किए जाते हैं या फिर वट एवर इज द वर्ड इज टेक्निकली. ऑन द अदर हैंड मेनी अ टाइम्स इट इज अदर वे अराउंड. You assume the person is guilty and then you need strong evidence to prove he is innocent. Okay? This is nothing but null and alternate hypothesis. Statistically null and alternate hypothesis is just like relationship is 0 and it is null hypothesis. But here the null hypothesis is the person is innocent in the first case. And now you need evidence to disprove it. Okay. So please understand, in decision making, sometimes we know we will do an error, we try to reduce the error, and we might learn about different decision making theories, but this is very elementary thing. Okay, so suppose I have to go outside and I don't know, I might get hungry and after 3 hours. So there are two mistakes. Let's took it that way. I might go right now and my might feed hunger later on the road, and on the route I don't find anyone and I'm hungry. On the other hand, I eat right now, I am tired right now, then I go, then it is what we say, I am sleepy and those sort of things. So which sort of mistake you do, that's your preference. That is on the philosophical side. Coming back to statistics, this is how we understand error. Okay? So in reality, if the null hypothesis is true and you accept it, then there is no error. On the other hand, if the null hypothesis is false and you reject it, there is no error. That is what we are talking in these two squares, the green squares. What are the errors? The error is the null hypothesis is true but you reject it, or the null hypothesis is false and you accept it. Okay? So, these are two mistakes written in red in the square boxes. Now, what it means is simple. Those two errors are different. There is one thing called type 1 error and there is one thing called type 2 error. So, type 1 error is rejecting a true null hypothesis, and type 2 error is accepting a false hypothesis. This type 1, type 2 will be the basis of complete statistics. Please understand this. This box or boxes, 4 boxes, are primarily telling you the complete statistics where you have an hypothesis, because hypothesis is the beginning of inferential statistic, and then you either accept or reject based on the evidence you have or based on a test you do. So, reject a true null hypothesis is alpha, type 1 error. Now, alpha is also known as multiple things, we will not go in coefficient level. So, we can say type 1 error, which is sometimes denoted by alpha in many books, and type 2 error is denoted by beta. Now, it is very difficult to decrease both errors. This is what we have to understand. It is very difficult to decrease both errors. And the best part is, as this is a world of duality and philosophically if you go, if you reduce one error, the other error will increase. That is called alpha plus beta is equal to 1. You reduce alpha, you increase beta, you increase beta, you decrease beta, you increase alpha. So, therefore, we have to understand, why I am smiling is primarily because we try for perfectionism and what we say idealism, but it is not possible many a times, and we see the contradiction itself. Anyways, coming back. So, you want to reduce alpha, that is our generally focus, because that is the way we define our null hypothesis. In this case, in the statistical case, there is no relationship between one thing, x is causing y or y is causing x, x is related to y, whatever the way says. So, there is no relationship, that is null hypothesis. Okay? So, please understand this. Now, extracting this concept of decision making, your null hypothesis could be anything H1, you can say that, and your alternative hypothesis could be H2. Now, what is H1, what is H2, that is up to you. How do you define it? H1 was true, but I rejected it, and H1, H2 was true, I rejected it. Both are different errors. You name it. Which one want you to reduce? Your choice. One error, दोषी को खाली छोड़ दो, दूसरा निर्दोष को सजा दे दो, दोनों गलती हैं. आप किसकी कमी करना चाहेंगे? Okay. So, this concept is not just hinge on statistics. This concept applies on decision making. Very thing. Though this is a very simple decision making, there are multiple parameters. I am not saying ki that's all, but on day-to-day line, either do this or do that. So, hypothesis 1 is do activity 1, hypothesis alternate hypothesis don't do activity 1. Like take a job, like in my case a food example, hypothesis 1 is to take the food, hypothesis 2 is not to take the food. Simple. Mistake says I took the food because I assumed there will be no food outside, and I found food outside. So, I am feeling lethargic. Other sort of mistake, I assume food will be there. And I went, and there is no food. Okay. So, in that way, this concept of alpha and beta, type 1 error and type 2 error combine is always 1. You cannot reduce both of them simultaneously. It's best you can get correct. Okay. Therefore, many times if you see in model fitting also, we are trying to reduce the error, because assumption if we reduce the error, our fit is better. The focus is not to get more fit, the focus is to reduce the error. You understand the difference? Operationally they are same. When you try to execute, it's the same thing. Okay. So please understand that. That's the thing. Now there comes something called for the level of errors. So suppose I say medically, clinically, if we take this medical 100 times, I have found this medical to give treatment to 80 people, 20 people are not affected. Okay? Please listen me out, this is more about hearing. On the other hand, I gave a medicine 100 times and I find 90 people getting recovered. Okay. On the other hand, I give 100 medicines, I find 95 people, or I give medicine to 100 people, I find 95 people getting cured. Which will be more accurate? Obviously the 95 one. But please understand this, there is cost associated with taking or reducing errors from 20% of people not getting it to getting 5% people of not getting it. Okay? And it is your personal statistical choice whether you want to work at 90% or whether you want to work at 95% accuracy. I don't know if you have seen the movie Mission Mars, Mangalyaan, that's what I think. And I think in a conversation it was said Mr. APJ Abdul Kalam is ready to go on the expedition or on the mission even though there is a 0.001 chance of succeeding. Now you might call this as irrational, that's your choice, that there are 99.99 chances of failure. But as I tell you, it's your personal choice, this is your decision. Statistics will tell you something, this much chance, that much chance. But what do you do with that? Okay? So, this is very important. Our level of confidence in the test. Like the case 100 people, 80 people getting cured, you are not that confident when you take the medicine. You are more confident when 100 people are taking, 90 people getting cured. Okay? So, it is again probabilistic. You are not very sure, but still you are assuming, okay, this much is there. So, please understand this concept. This is very nicely tied up. One is type of error you want to focus on, and by how much % you are ready to accept it. I don't know if you remember the COVID times. There were clinical trials and there were talks like this, our medicine is 85% accurate or 90% accurate or 95% accurate. And we were trying to go for more accuracy And the more we were trying to go to more accuracy, the more we were trying to delay the things, because I told you more accuracy comes at higher cost, either time wise or resource wise. And there were some countries which you might say they operated medicine बहुत जल्दी आ गई, but those accuracies were less. So decisions is yours, the decision maker. Statistics is just a tool. You can fit parameters, that's fine, but that parameters has to come by you or a decision maker. Okay, so please understand, we have a term called hypothesis. We have a term called level of type 1 error, which is rejecting a true null hypothesis. When it is true, we reject it, and then there is a confidence in the hypothesis or the evidence. These are the three things which you need to understand before we start developing any sort of test. So this is where things rotate. All our attempts will be about this only. Is this relationship there? I don't know if you saw our slides where we took the curve fitting and I showed you there were some R square and P values. We can see that. You can go back in the last lecture. Okay. So P values. Those P values are probability of type 1 error. Lesser is that, better it is. In statistical terms, statistical tests, there is a concept called P value, which is probability value of the error, probability of type 1 error. Some people will accept that at 5%, some people at 1%, some people at 0.1%, some people at 10%. General rule is 5%. Okay. So please understand this, that here also probability has been told. What does probability means? If in the population of let's say lakh people, I am assuming that motivation will cause them to study, and then I studied 100 samples. If I am saying my probability value of type 1 error is 5%, it means only in 95 at least 95 people I will find where this concept will be true, that motivation is causing them to study, which means my error is less than 5%. Therefore, we set an upper limit to error. We want at least alpha to be at max. You will study 0.05. This 0.05 number is very famous. Alpha, which is a probability value. Okay. So therefore, I said alpha is independent multiple times. Sometimes people say alpha is type 1 error. Sometimes people say alpha is the upper limit of significance, upper limit of the type 1 error. So let's be very simple. There is type 1 error and there is a level of type 1 error. So you have marks and you have cutoff marks. भाई 50 नंबर से कम आएगा तो इनका एडमिशन नहीं होने वाला. That is what a cutoff means. So you have marks, the probability of error happening, and you have a cutoff level. Just like in this case, 100 times if you conduct the test, 100 samples you take, you find motivation to be related to studies, 95%. Now this hypothesis is even more stronger if you find 99 people. Then you say my test is accurate and the error is only 1%. But as I told you, higher errors comes at higher prices. Lesser error comes at higher prices. That is your choice. Okay. So with that, we end the basics of what is hypothesis, what is error, how it is related to probability, and we will talk about it more as we go ahead when we will be studying confidence interval level. Thank you very much.